possible battery pack company similar in name is Chlorine. Several reasons exist for having two pairs of lights in exit signs. Firstly, redundancy. One pair of lights serves as a backup in case the other fails. Secondly, different wattages. The two pairs of lights may have different wattages to provide varying levels of illumination. Thirdly, lifespan. The two pairs of lights may have different lifespans, allowing for easy replacement when one set burns out. Fourthly, emergency and normal operation. One pair may be for emergency operation, for example, during a power outage, while the other pair may be for normal operation. Fifthly, low voltage and high voltage. In some cases, one pair of lights may be designed for low voltage, for example 12 volts, and the other pair for high voltage, for example 120 volts. Other emergency lighting manufacturers include Eagle Eye Power Solutions, Exide Technologies, GMB Industrial Power, Hawker Energy Products, and U.S. Battery Manufacturing. When diagnosing emergency lighting issues, begin by checking the battery pack. The battery pack should be fully charged and properly connected. Examine the lamps in both the battery pack and the exit lights for any signs of damage or burnout. If the lamps appear intact, use a multimeter to test the voltage at the lamp sockets. The voltage should match the specified voltage of the lamps. If there is no voltage, trace the wiring back to the battery pack and check for any loose connections or breaks in the wires. The battery pack itself may have internal fuses or circuit breakers that need to be checked. Use a multimeter to verify the continuity of these protective devices. If the battery pack has a test button, pressing it should activate the emergency lights. If the lights do not activate, it could indicate a faulty battery, a defective test circuit, or a problem with the wiring. Verify that the battery is holding a charge and providing the correct voltage. The voltage should be within the specified range for the battery pack. The battery pack may also have indicator lights or a display that provides information about its status. Refer to the manufacturer's instructions for interpreting these indicators. Inspect the wiring connections between the battery pack and the exit lights. Look for any signs of corrosion, loose connections, or damaged wires. Clean and tighten any loose connections. If the wiring is damaged, replace it with new wiring of the same gauge and type. The exit lights themselves may have internal components that can fail, such as transformers or ballasts. Use a multimeter to test these components for proper operation. If any of these components are faulty, they should be replaced. Some exit lights have a self-testing feature that automatically tests the emergency lights at regular intervals. If the exit lights have this feature, check the test results to see if there are any reported errors. Refer to the manufacturer's instructions for interpreting the test results. The emergency lighting system should be tested regularly to ensure that it is functioning properly. Perform a manual test of the system at least once a month and a full discharge test at least once a year. Keep a record of these tests, including the date, results, and any corrective actions taken. During a power outage, the emergency light should automatically activate and provide sufficient illumination for occupants to safely evacuate the building. If the emergency lights do not activate or provide insufficient illumination, investigate the cause and take corrective action immediately. The National Electrical Code, or NEC, contains requirements for emergency lighting systems. Ensure that the emergency lighting system meets all applicable requirements of the NEC and any other applicable codes or standards. Consult with a qualified electrician if you are unsure about any aspect of the emergency lighting system. Emergency lighting systems are an important safety feature in any building. By following these troubleshooting steps, you can help ensure that the emergency lighting system is functioning properly and providing a safe environment for occupants. The NEC, specifically Section 700, covers emergency systems. These are intended to automatically supply illumination or power to designated areas and equipment in the event of failure of the normal supply, or in the event of accident to elements of a system intended to supply, distribute, and control power and illumination essential for safety to human life. Emergency systems are typically required in buildings where immediate and automatic illumination or power is necessary for life safety. NEC Section 700.12 covers the types of acceptable power sources for emergency systems. These include storage batteries, generator sets, uninterruptible power supplies or UPS, and separate services. Storage batteries must be of suitable voltage and capacity to supply the emergency lighting and power for a minimum of 1.5 hours. Generator sets must be sized to supply all required emergency loads and must be equipped with automatic starting and transfer devices. UPS systems must be capable of providing power for a minimum of 1.5 hours. Separate services must be supplied from a different location than the normal service and must be independent of the normal service. NEC Section 700.16 covers the illumination requirements for emergency lighting. Emergency lighting must provide adequate illumination to allow for safe egress from the building. The illumination level must be maintained for a minimum of 1.5 hours. NEC Section 700.26 covers the testing requirements for emergency systems. Emergency systems must be tested periodically to ensure that they are operating properly. The testing must be conducted in accordance with the manufacturer's instructions. Emergency lighting systems play a critical role in ensuring the safety of occupants in a building during a power outage or other emergency situation. Regular inspection, testing, and maintenance of these systems are essential to ensure their proper operation. It is important to consult the specific requirements of the NEC and other applicable codes and standards to ensure compliance. Regarding battery packs, their voltage and capacity are crucial factors. The voltage must match the requirements of the connected emergency lights or equipment. The capacity, measured in amperes or Ah, determines how long the battery pack can supply power. The required capacity depends on the total load and the desired runtime. Batteries should be tested regularly to ensure they can deliver the rated voltage and capacity. Load testing can reveal whether a battery is nearing the end of its life. Proper ventilation is essential for battery packs, especially those using lead-acid batteries, as they can release hydrogen gas during charging. Overcharging can damage batteries and shorten their lifespan. Battery packs often include charging circuits that regulate the charging process to prevent overcharging. Environmental factors, such as temperature, can affect battery performance. Extreme temperatures can reduce battery capacity and lifespan. Battery packs should be stored and operated within the manufacturer's recommended temperature range. Proper wiring and connections are essential for reliable operation. Loose or corroded connections can cause voltage drops and reduce the performance of the emergency lighting system. Wiring should be sized appropriately to handle the current load. Fuses and circuit breakers protect the battery pack and connect equipment from overcurrent conditions. These protective devices should be sized appropriately and inspected regularly. Emergency lighting systems are designed to provide illumination during a power outage, enabling occupants to safely evacuate a building. Exit signs indicate the direction of egress and must be clearly visible even in low light conditions. Emergency lighting units, often powered by battery packs, provide supplementary illumination to ensure safe passage. The NEC and local building codes specify the requirements for emergency lighting systems, including the required illumination levels, placement of exit signs and emergency lights, and testing and maintenance procedures. The NEC Section 700 addresses emergency systems, while Section 701 covers legally required standby systems, and Section 702 covers optional standby systems. Emergency systems are essential for life safety and must be reliable and well maintained. The authority having jurisdiction, or OJ, typically enforces these codes and standards. Regular inspections by the AHA ensure compliance and identify any potential issues. Emergency lighting systems should be tested monthly to verify that the battery packs are charging and the lights are functioning properly. A longer annual test, typically lasting 90 minutes or more, verifies that the system can provide illumination for the required duration. Test results should be documented and any deficiencies should be addressed promptly. Proper maintenance of emergency lighting systems includes cleaning the lights, replacing batteries as needed, and inspecting wiring and connections. Batteries typically have a lifespan of several years, but this can vary depending on the type of battery and the operating conditions. Consider the ingress protection, or IP, rating of emergency lighting fixtures, especially those installed in damp or wet locations. The IP rating indicates the degree of protection against dust and water. Select fixtures with an appropriate IP rating for the environment. When specifying emergency lighting systems, consider the aesthetics of the fixtures. Choose fixtures that complement the building's design and decor. LED technology has become increasingly popular in emergency lighting due to its energy efficiency, long lifespan, and instant-on capabilities. LED emergency lights are available in a variety of styles and configurations. Consider using a centralized emergency lighting system, which uses a single battery bank to power multiple emergency lights. Centralized systems can be more cost-effective and easier to maintain than individual battery packs for each light. Addressable emergency lighting systems allow for remote monitoring and control of individual lights. These systems can provide real-time status information and facilitate testing and maintenance. Emergency lighting systems should be designed to minimize glare and provide uniform illumination. Glare can impair visibility and make it difficult for occupants to evacuate the building safely. Uniform illumination ensures that all areas are adequately lit. Consider the color rendering index, or CRI, of the emergency lights. A higher CRI indicates that the lights will render colors more accurately, which can be important for identifying hazards and navigating the building. Emergency lighting systems should be designed to be vandal resistant. Fixtures should be securely mounted and protected from tampering. Consider using emergency lighting fixtures with battery backup and generator backup for enhanced reliability. If the battery fails, the generator will provide backup power. Emergency lighting systems should be designed to be compatible with the building's fire alarm system. The fire alarm system can activate the emergency lights in the event of a fire. Emergency lighting systems should be designed to be accessible for maintenance. Fixtures should be located in areas where they can be easily reached for cleaning and replacement. Emergency lighting systems should be designed to be energy efficient. Use LED technology and other energy-saving measures to reduce energy consumption. Emergency lighting systems should be designed to be environmentally friendly. Choose fixtures that are made from recycled materials and are recyclable. When specifying emergency lighting systems, consult with a qualified lighting designer or engineer. They can help you select the appropriate fixtures and design a system that meets your specific needs. Proper installation of emergency lighting systems is essential for their reliable operation. Hire a qualified electrician to install the system in accordance with the manufacturer's instructions and applicable codes and standards. Regular inspection, testing, and maintenance of emergency lighting systems are crucial for ensuring their proper operation and the safety of building occupants. The battery pack you reference might not be from Chlorine, so it is important to look into other manufacturers. These companies include Eagle Eye Power Solutions, Exide Technologies, GNB Industrial Power, Hawker Energy Products, and U.S. Battery Manufacturing, so make sure to compare all of your options and consult with a professional.